Hello everyone, my presentation is about the phase topology and bifurcation theory of the hydrogen atom subjected to external fields. We have as plan introduction, algebraic structure, topology analysis, numerical investigation, and conclusion. Most natural phenomena are generally governed by a nonlinear differential equation. For this problem, we must use different mathematical approaches and computational methods to simplify the system and to study their integrable, like the algebra, duple level analysis, Ziegler theorem, Liouville theorem, and the Poincaré section. The study of the hydrogen atom has been recently the focus of many works. Its great importance lies in its field of application in different branches of physics: solid-state physics, spectroscopy, plasma physics, molecular physics. This part is devoted to the study of the common level set of the first integrable in order to describe the topology of the phase space of the problem. So we consider the problem of the hydrogen atom perturbed by van der Waals potential interacting with combined electric and magnetic field. This problem is described by the Hamiltonian, where alpha is a constant, beta measured in unit of electric field, gamma measured in unit of magnetic field, and lambda control the harmonicity associated to the van der Waals potential. We need a change of coordinates that make the problem separable, and therefore we can express the second invariant, indeed either the elliptic transformation. So the Hamiltonian is written in this form. So the letter system is separable, and therefore the second invariant can be expressed. And from the last Hamiltonian one can express the first integral f. One can also express the system of differential equation. In this section we will give the topology of real level sets. Since the system is separable, then its trajectory is on a real variety AR. We find two cases according to the values of alpha superior than 0 and alpha inferior than 0. To do this, we find the bifurcation diagram B, which represents the set of critical values of the invariants H and F. And here is the bifurcation diagram B, which has 9 domains. We find the topological type of AR in the domain in each domain. In the domain 1 and 2. Set empty in the domain 3 a torus, in the domain 5, 6, 7, 8 2 torus, and in the domain 9 a torus. In this part we are interested in the variety AR for values generic of HF in the diagram de bifurcation. We will limit ourselves to the 3 types of bifurcation: a torus narrow into a circle and then disappears, 2 torus narrowed into 2 circles and then disappeared, 2 torus merge into a torus. And here is the bifurcation diagram B for alpha inferior than 0. And here the topological type of AR for each domain. By making use a set of software routine implemented in Maple for plotting 2D projection of Poincaré surface of section method introduced by Poincaré and extended by Henon, we give numerical illustration of the real phase space topology studied in the previous section for fixed values of constant HF, lambda, beta, and alpha, gamma vary. The Liouville theory contained in the level set change their topological type while preserving the integrable behavior of the problem. We see that in the integrable case, alpha equal 1, gamma equal 1, the structure is regular If we vary a little, the parameter make the structure chaotic, and this is clearly visible in the figure. From these figures, it is deduced that the parameters alpha, gamma, and lambda have the same influence on the system to the chaos, except the parameter beta, which has influence weak. In conclusion, we have studied the classical dynamics of the hydrogen atom perturbed by van der Waals potential interacting with combined electric and magnetic field. By making use of some reduction, the regularized Hamiltonian of the system is described by a 2 degree of freedom dependence on certain control parameters. The different results obtained show the capacity of the method used to provide precise information on this Hamiltonian system. The very important question as we have studied is the topological analysis of the real invariant manifolds AR of the system. Forming theory and chirurgy and the bifurcation of the W.Chatar has been combined with that of the algebraic structure to give a rigorous and detailed description of the topology of invariant manifolds. We have also numerically illustrated the generic bifurcation of the W.Chatar and the regularity chaos transition when the control parameters vary.